Here's a video to help you out with some of the Chapter 10 Khan Academy assignments I've assigned. I know that we learned a lot of this quickly. A lot of this info is found in your Chapter 10 toolkit, and we did some practice problems in your Chapter 10 study guide as well. So I put together this PDF of different problems from your Khan Academy to hopefully help you complete those assignments with full credit. So if you do any of them late, you need to get 70% or above to get full credit. Please email me so that I can update your grade. Okay? So you'll notice that at the top here of each of I think I did 2 problems per practice approximately. That's the name of the assignment. So you can always do the practice problems with this video and then pause before I get to the next assignment and go do the assignment on your own. Okay, so it's totally up to you how you want to do this, but you do need to complete this entire video and take notes on all of these problems, even if you've already done the Khan Academy. Okay. Okay, so let's go and get started. Here it says if angle ADC measures 23 degrees, what does angle ABC measure? Well, angle ADC is right here, okay, because it goes A to D to C. So I know this is 23 degrees, and it's asking me what does angle ABC measure? So ABC is this angle right here. Well, this orange angle here is what we call an inscribed angle. It does not go to the center, okay, so it's an angle that's not created by being on the center, it's on the edge of the circle, but its endpoints share this same central angle. So this blue angle here is a central angle. And if you look back at your notes, we know that inscribed angles are half the measurement of central angles. So 23 is half of what that central angle is. So twice of 23, double it is 46 degrees. So the central angle must be 46 degrees here. Okay, so you can think of it as the central angle is twice the amount of the inscribed angle, or the inscribed angle is half of the central angle. And I'm going to go through these as quickly as I can while explaining it, so if I ever go too fast, just make sure to pause, okay? You have control to pace yourself throughout this video. Alright, a circle is centered on point B, so I know B is my center. Points A, C, and D lie on its circumference, so the circumference is the edge of the circle here. That is its circumference. If angle ABC measures 40 degrees, which would be right here, ABC, make sure that you're good with how to name angles. That's super important. We're told that's 40 degrees. What does angle ADC measure? So ADC is this inscribed angle right here. Well, we know that inscribed angles are half of the central angles that they share endpoints with. So A and C, they share those endpoints on the angle. So the inscribed angle is half of 40, which would be 20 degrees. Once you know how to identify an inscribed angle versus a central angle, then it becomes a lot easier for you to identify what their measures are if you know one of them. All right, so now here's the next practice. So tangents of circles problems. So we're told here that line AC is tangent to circle O at point C. So whenever something is tangent, that means it is perpendicular, or actually, okay, sorry. Tangent means it touches the edge of the circle one time. And when it shares a point with the radius or diameter, like it does right here, then those two lines are perpendicular. So a tangent line to the circle touches the circle one time at one point. When it shares that point with the radius or diameter, then we know that creates a 90-degree angle because it would be perpendicular. So that's super important. As soon as you know that something is tangent, you want to see, okay, is it connected to any radii or diameter? Okay. So here it says, what is the measure of angle ACO? Oh, that one's nice. I already did it for you. So ACO is that right angle right there. So this was testing your knowledge to see, okay, do you know that whenever there's a tangent line that meets the radius or diameter, that it's perpendicular? This would show that you did know it. So it's 90 degrees. Okay, and this is point C. We would call that the point of tangency. That is where the tangent line touches the circumference or the edge of the circle. All right, angle A is circumscribed about circle O. What is the measure of angle A? All right, so let's look at angle A. So angle A is right here, right? So we know that I see this inscribed angle over here, the 65 degrees. So that is an inscribed angle. What that shows me is that here, where that angle touches the edge of the circle there at B and here at C, that's also where this central angle touches the edge of the circle. So this central angle is twice the measurement of the 65 degrees there, okay? So this is important for us to know here. So if this one here is 65 degrees, the inscribed angle, then the central angle is twice the number of the inscribed angle, the degrees. So 65 times 2 is 130 degrees. That tells me that this arc here is also 130 degrees. Okay. Now looking here, it looks like these lines from A to C, it looks like that is a tangent line. Like that could keep on going if I had not stopped it on that point. So I want to take us back over to our Chapter 10 toolkit, and I want you to imagine this image in your head. Okay, so let's go look at the Chapter 10 toolkit. I'll just go to 7th periods. So we had a whole bunch of pictures here, if you guys remember this. And here's one that looks kind of like what we just had on our screen. So I'm going to take a little snippet of this just so that we see how you guys can use the Chapter 10 toolkit on your own problem. So I would be looking and say, okay, this one looks similar. So let's go put it side by side with that practice problem and see if it helps us see how we can solve this problem. So let me insert that in here. All right, I don't know why it hasn't, whoops. I don't know why it hasn't been cropping them like I want it to. Let's do that. Okay. All right, so yes, ours is rotated a little bit, but you see here that these are also tangent lines if they were to be extended. So I know that in order to find the measure of angle A, that is going to be, you guys see the big arc that is outside of this. So I'll show you, let's make it orange. This arc measurement here, from where it touches there, all the way across. I need to know the measurement of that arc. So we'll call that X, just like the formula. So I need to know the measurement of X, and then I need to know the measurement of this inside one, which we actually do, but we'll call that one Y. X minus Y divided by 2 will give us the measurement of this angle A that is outside of the circle and has 2 tangent lines that touch the circle. Okay, so we take the bigger arc and subtract the smaller arc from that and then divide by 2. Well, if we know that the smaller arc is 130 degrees and an entire circle is 360 degrees, okay? The entire circle is 360. So that orange part is 360 minus 130. So this will be 230 degrees, okay? So now I know that X is 230 degrees. And let me just make this all a little bit smaller. If I know x is 230, and I knew that y was 130, so 230 minus 130 divided by 2 will give me the measurement of angle A. So the measurement of angle A equals 230 minus 130 is 100 over 2 is 50 degrees. So make sure that you have that Chapter 10 toolkit open and ready to be used, whether you did it on paper or have it open in another tab in Kami. Make sure to use that. Okay. All right. So let's see this one now. Here's another tangent one. Okay, cool. So this one is a challenge problem. It's within the article, and I still want you to do it. I still would like you to do those problems. So this is from the article, and you can even look at their steps too if you wanted to see another explanation after seeing mine. So here I know that AC is tangent to circle O at point C. So point C is where my tangent line touches my circle. And you notice here that this is OC is a radius. So we know that whenever a tangent line shares a point with a radius or a diameter, then that is a right angle because they're perpendicular. So now I know I have a right triangle, and it's asking me what is the length of OC. So I'm trying to find this length here of this radius, x, OC. Okay? So there's a few different ways that we can do this. First of all, I want us to recognize that this is a right angle. We can use the Pythagorean theorem, okay? So here we're asked to find the radius. You guys will notice that this is also the radius here. So let's also call that x, okay? So here, if we were to use the Pythagorean theorem, I want us to just redraw this triangle here. So I'm just going to redraw this right triangle. I know that that bottom length is 4. The hypotenuse here is 2 plus x. And this length here is x. Let's see if we can find what x equals. Okay? So here, and this is a challenge problem. That's why it was called challenge problems, right? So here, what we can use is we'll label the legs as a and b and the hypotenuse as c. The Pythagorean theorem is a squared plus b squared equals c squared. So we can substitute in what we know about this right triangle to solve for x. So we know a is 4, b is x, and c is 2 plus x squared. So you see there, that's going to be multiplying two binomials together. So 2 plus x squared is the same as 2 plus x times 2 plus x. Sorry, I'm a little bit sloppy right now. Okay, 2 times 2 is 4. 2 times x is 2x. X times 2 is 2x. X times x is x squared. So here's what we have. 4 squared is 16. X squared is x squared. Equals this here. We can combine like terms to be x squared plus 4x. 2x plus 2x is 4x plus 4. So now we want to solve for x. Okay, now we have an equation where we can solve for x. So first of all, I'm going to subtract x squared from both sides because look at what happens. They cancel out. So now I have 16 equals, right, because that's our little line, equals 4x plus 4. Okay. I'm going to make this all a little bit smaller. Oops. All right. So now I can subtract 4 from both sides. I'm going to get 12 equals 4x. Divide both sides by 4. X equals 3. And that would be our radius. And that makes sense too, because then if that's 3 and the other leg is 4, and this would be 2 plus 3, which was 5, if you were to test the Pythagorean theorem again, it would be that 3 squared plus 4 squared should equal 5 squared, if we solved it correctly. 3 squared is 9, 4 squared is 16, 5 squared is 25. Does 9 plus 16 equal 25? Yes, it does. That's actually a Pythagorean triple. That's a perfect little Pythagorean triangle. Okay, so the length of OC is 3, long story short. And that's why these were called challenge problems. All right, so now here's another one with the tangent. So it says here that the line AC is tangent to circle O at point C, right? So this line here is tangent at point C, which means that since there's a radius here, OC, this is a right angle. So once again, I have a right triangle, and they want to know what is the length of OC. So if we label that as X, oops, we know that OB is also X because those are both radii of the circle. So I can also say, okay, that's also X. They're equal, okay? So again, we can redraw this triangle as a right triangle. This kind of helps us visually see it. The bottom here is 30. The right side is X. And then the hypotenuse is 18 plus X, or you can also write X plus 18. So the Pythagorean theorem is a squared plus b squared equals c squared. Well, the legs are a and b. It doesn't matter which one's which. The hypotenuse is always c. So we have 30 squared plus x squared equals x plus 18 squared. Okay, so 30 squared is 900 plus x squared equals, so this will be, I'm going to do this in my head, but again, you guys could always, I might as well just do it here. So if I multiply that, x squared, 18x, 18x, and then that one, 18 times 18, let's see, it's 324. So it'll be x squared plus 36x plus 324. So once again, we want to solve for x, subtract the x squared from both sides. So now we have 900 equals 36x plus 324. Okay, so we have 576 equals 36x. Divide both sides by 36. And again, guys, I'm going to go through these fast, so if you need to pause to get caught up, please do so. So 576 divided by 36, 16. That's a nice number. 16. Okay, so you should get x equals 16 because that would be the length of OC here. So the radius of the circle is 16 units. Right, so those were challenge problems, and that's what you were expected to do in that article. Also, take a look at how they solve them. I'm interested to see if anything's different or if they're the same. So take a look at their solutions as well. All right, so here's some more arc measure practice with circles. So this is something that we did work on last semester, okay? So it's coming back, and we want to get even better at it this time. So we're told that BD, okay, BD and AC are diameters of circle P. What is the arc measure of minor arc DC in degrees? So we want to find the measure of arc DC here. So we just have to start to use what we know, okay? Well, I know that this measurement here is 19 degrees. If that's 19 degrees, then its vertical angle is also 19 degrees. And since we know that these are diameters, we know that this is the center of the circle. So this is a central angle. So is the other one on the right, the other 19. This is the central angle here, one of the central angles. So we know the central angle is always equal to its arc. So the measurement of arc DC is 19 degrees as well. So a lot of this is just understanding, what is equal, what is half, what is twice the amount, so it's really just reading carefully what they want and using what information is given to you to get to that point. Okay. All right, here again it tells us that the line AB is a diameter of this circle, so that means that P is our center. The diameters always go through the center. This is the center. Okay. It says, what is the arc measure of major arc ABC in degrees? So let's see here. We want to know the arc of ABC. So we go from A to B to C. I want to see if maybe you can think about that yourself for just a few seconds. How would you solve this? We know that if this is the central angle here, then this arc right here, BC, is also 69 degrees. Okay? And then here I have a diameter, and a diameter is a straight line through the circle. So this AB arc is 180 degrees. So ABC is adding together 180 plus 169, plus 69. So 180 plus 69 degrees, 249 degrees. That would be your answer for the measure of the major arc. Okay. So now we have arc measure with equation, so it gets a little bit more difficult. What is the arc measure of minor arc AD in degrees? So our goal is to find this arc measure right here, AD. Now it tells us again that AB is a diameter. AB is a diameter. So that means PC and PD are radii, so those are radiuses there. Okay, before we can know the measure of angle AD, or the arc AD, we need to know what x equals. So since we know that circle, or that AB is a diameter of circle P, we know that these three angles right here add up to 180, so that's a straight line. So I can set up an equation, 7x plus 1 plus this right angle here is 90 degrees, plus 90 plus 9x minus 7 equals 180. Okay? So now you have an equation where you can solve for x. So pause the video and try it out on your own and then check your work with mine. I'll go pretty fast. 7x plus 9x is 16x. 1 plus 90 minus 7, that would be 84, equals 180. Subtract 84 from both sides. Get 16x equals 96. Is that 6? 16 times 6? Yeah. Divide both sides by 16. We get x equals 6. That's not what they're asking us for, though, right? We have to use that knowledge to find the measure of minor arc AD. So first, if this angle measurement is equal to 7x plus 1, we know x is 6. 7 times 6 is 42 plus 1 is 43. So I know that this central angle right here is 43 degrees, which means its arc is also 43 degrees. Central angles are always equal to the arc that the angle creates, like that. Okay? So this is 43 degrees. All right, I'm just curious how many more I put on here. Okay, good. So we have 3 left, okay? So in the figure below, the segment AD and BE are both diameters. So let's go in and look at those. So AD is a diameter and BE is a diameter as well. Okay? So what that means is that whenever we have two diameters, the center is here at P. And what this tells us, what the diagram tells us, is that where these two diameters cross, it creates a 90-degree angle. So that's a 90-degree angle here, here, and here. If it creates one 90-degree angle, it's all the way around 90 degrees. Okay, so keep that in mind. So here it says, what is the arc measure of major arc CAD in degrees? So let's see here. This one's going to be a bit of work. Major arc CAD. You notice here how I did not go from C to D. It told me CAD, so I had to go from C to A to D in order to know which arc I was working with here. Okay, so that's how I always want you guys to do, is follow the arc name, CAD. So that's what I need to find. We know a few of these already. So I already know that this arc measurement right here, this 90 degrees is the central angle, so this arc measure is also 90. And since this is a straight line, and this is a straight line, this here is also 90. 90 plus 90 is 180. So then I know this arc measure here from A to B is also 90 degrees. Okay, so we're making progress here. I need to solve for K. So I can't use this at all to solve for K. I don't know anything about that angle measurement or what this angle measurement is. I have no idea. All I know is that those two add up to 90, but I don't know what this one is at all. So I have to ignore this part of the circle for just a bit. But I do know that here, that's a 90-degree angle. So I know that 33K minus 9 equals 90. And now here I can solve for K, and then I'll be able to solve for the rest of that part here that I crossed out. Okay? So my first step, I'm going to add 9 to both sides. I have 33K equals 99. Divide both sides by 33. I get K equals 3. Now that's not what they asked us for. They asked us for the major arc CAD, but K, it looks like, oh, forgot to mention, this here, this part of the arc is also 90, right? If this central angle in here is 90, then that's also 90. So we know almost all of the arc CAD, but we are missing this part of the arc here. We don't know what this is yet. That's why I needed to solve for K. So now that I know what K is, I know that this here is 20 times 3 plus 4. 60 plus 4. This measurement here is 64 degrees. So that means that this measurement here is 90 minus 64, because I know that this is a 90-degree angle here. So 90 minus 64 is 26. So now I know if the central angle is 26, then this part of the arc here is 26 degrees. So I need to add together 26 plus 90 plus 90 plus 90. So that's 270 plus 26 is 296 degrees. And then we're good to go. Okay. All right, arc length. So we have to use our knowledge of circumference here. Okay. I guess I didn't assign area of a sector. I'm sorry if I just forgot to put that on here. But if I did assign area of a sector, then just make sure to review past notes. Use the Khan Academy video to refresh your memory. It is something we've done. It looks like I only have arc length on here, so I can't quite remember at the moment. All right, so a circle with circumference 18, which means the circumference is all the way around. So the length around the circle is 18. It has an arc with the 120-degree central angle, and it wants to know what the measurement of this arc with the 120-degree central angle is. So if the central angle is 120 degrees, then that means that my arc measurement is also 120 degrees. So this is 120 out of 360 degrees. Is that part of the circle? And that's the part of 18 units, which is the circumference. So we can simplify 120 over 360 over to 1/3 times 18. 1/3 times 18 is 18 over 3, which is 6. So the length of the arc is 6. And this is the same idea if you had been given the area. You would take the fraction of the area of the sector and just multiply them together. Okay? Multiply that by its area. Alrighty. This one, it says a circle has a radius of 3. So I see that right here. This is the radius. So that means this is the center. Okay? An arc in the circle has a central angle of 20 degrees. So if the central angle here is 20, then this arc measurement is also 20 degrees. It says, what is the length of the arc? Well, first I need to know what the circumference is. So the circumference is very important to know the length of just a part of the circle. I need to know the length of the entire circle. The circumference of a circle is always 2 times pi times r. It says here that we can either leave our exact answer in terms of pi or use 3.14 for pi and enter our answer as a decimal. So it's totally up to you. I'll just go ahead and leave it in terms of pi, okay? So that means I'm just going to leave pi in my answer there, all right? So here I know my radius is 3, so my circumference is going to be 2 times pi times 3. So my circumference is 6 pi. 2 times 3 is 6. So now the arc length is going to be the fraction of the circle, so it's 20 degrees out of 360 degrees times my circumference, which is 6 pi. So with that fraction there, I always want to reduce it. I know I can divide the top and bottom by 20. That's going to be 1 over 18. So my new fraction is 1 over 18 times 6 pi. If you multiply that together, you're going to get that the arc length is 6 pi over 18, which you can reduce down to 1 pi over 3. And you can always put this into your calculators of 3.14 over 3 and give Khan Academy an estimated decimal there. I recommend just putting it right in as pi over 3, just in case you mess up rounding any decimals or anything. Okay? But hopefully this helped you knock out these Khan Academies. Again, please email